Hi everyone, welcome back. In this lecture, we are going to understand Spring Boot architecture in a simple and beginner-friendly way. We will follow the complete request and response flow of a typical Spring Boot REST application. We will understand how a request travels from a browser or mobile application to the Spring Boot application, reaches the database, and finally returns a response to the client. We will also understand the important layers used in a Spring Boot application and the core features that make Spring Boot development faster and easier. Let's begin with the overall architecture. A typical Spring Boot application contains a client, an embedded web server, a controller layer, a service layer, a repository layer, and a database. The request moves from the client toward the database. After the required operation is completed, the result moves back through the same layers and is returned to the client. Let's understand every step in the correct order. The first step is the client request. A client is any application that communicates with our Spring Boot application. The client can be a web browser. It can be a mobile application. It can be a front-end application developed using Angular, React, or another framework. It can also be an API testing tool or another backend service. The client sends an HTTP request to the Spring Boot application. For example, the client may send a GET request to get/API/users. This request may ask the application to return a list of users. The client may also send a POST request to post/API/orders. This request may ask the application to create a new order. An HTTP request normally contains several pieces of information. It contains an HTTP method such as get, post, put, patch, or delete. It contains a URL that identifies the requested resource. It may contain request headers. It may also contain a request body, usually in JSON format, when the client wants to send data. Once the request is sent, it reaches the embedded server inside the Spring Boot application. The second step is the embedded server. One major feature of Spring Boot is that the web server can be included directly inside the application. Apache Tomcat is commonly used as the default embedded server for Spring Boot web applications. Depending on the selected dependencies and configuration, Spring Boot can also use other embedded servers such as JT. In traditional Java web development, developers often created a WAR file and deployed it manually to an external application server. Spring Boot simplifies this process. We can package the application as an executable jar file. For example, springbootApp.jar. When we run this jar file, the Spring Boot application starts as a standalone application. The embedded server also starts automatically. This means we do not need to install and configure a separate Tomcat server for normal development and deployment. The embedded server listens for incoming HTTP request. When the client sends a request, the server receives it and passes it into the Spring Web application. Spring then identifies the controller method that should handle the request. That brings us to the controller layer. The third step is the controller layer. The controller layer is the entry point for incoming HTTP request inside the application. In a REST application, we commonly create a controller class using the REST controller annotation. The REST controller annotation tells Spring that this class contains REST API endpoints. We can use request mapping at the class level to define a common base URL. We can then use annotations such as get mapping, post mapping, put mapping, and delete mapping to map individual HTTP requests to Java methods. For example, suppose the client sends get/API/users. Spring checks the available controller mappings. It finds the controller method mapped to this URL and HTTP method. That method is then called. The controller layer handles the web-related part of the request. It can read path variables from the URL. It can read query parameters. It can read HTTP headers. It can also convert a JSON request body into a Java object. The controller may also validate the incoming input when request validation is configured. However, the controller should not contain the complete business logic of the application. Its main responsibility is to receive the request, pass the required data to the service layer, and return the final response. So after understanding the request, the controller calls the service layer. The fourth step is the service layer. The service layer contains the main business logic of the application. A service class is commonly marked using the service annotation. The service layer decides what the application should do with the request. For example, suppose the client wants to create an order. The controller receives the request and sends the order data to the service layer. The service layer may calculate the total amount. It may check whether the requested products are available. It may apply business rules or discounts. It may decide whether the order can be created. It may also coordinate multiple operations required to complete the use case. The service layer is also commonly responsible for transaction boundaries. A transaction helps ensure that a group of database operations succeeds or fails as one unit. For example, creating an order may require saving the order and updating product inventory. If one operation fails, the transaction can roll back the completed changes to keep the database consistent. The service layer should focus on business decisions and application flow. It should not normally contain low-level database access code. For database operations, the service layer calls the repository layer. The fifth step is the repository layer. The repository layer is responsible for data access logic. It communicates with the database and performs operations such as create, read, update, and delete. These operations are commonly called CRUD operations. In Spring Boot applications, we often use Spring Data JPA to create repository interfaces. For example, a repository interface can extend JPA repository. When we do this, Spring Data JPA provides many common database operations automatically. We do not need to write the implementation manually for basic operations such as save, find by ID, find all, and delete by ID. Spring creates the required repository implementation at runtime. The repository annotation represents the data access layer, although Spring Data repository interfaces are detected automatically when properly configured. The repository works with entity classes. An entity represents data stored in a database table. For example, a user entity may map to a users table. An order entity may map to an orders table. When the service asks the repository to save or retrieve information, the repository communicates with the database through JPA and the configured persistence provider. The sixth step is the database. The database stores the application's persistent data. The diagram uses MySQL as an example. A Spring Boot application can also connect to other relational databases depending on the project requirements. The database organizes data using tables, rows, and columns. For example, a user's table may contain columns such as ID, name, email, and password. An orders table may contain the order ID, customer ID, amount, and order status. When the repository performs a read operation, the database returns the matching data. When the repository performs a write operation, the database inserts, updates, or deletes the required rows. The database result returns to the repository. The repository returns the data to the service layer. The service layer may apply additional business logic or convert the result into the required response format. The service then returns the result to the controller. The seventh step is response to client. The controller prepares the HTTP response. In a REST API, the response body is commonly returned as JSON. For example, the response may contain a status field and a data field. Spring automatically converts the Java response object into JSON when the required web support is available. The HTTP response also contains a status code. For example, status code 200 indicates that the request was successful. The embedded server sends the response back to the original client. The browser, mobile application, or REST client then receives the status code and response body. So the complete request flow is client request, embedded server, controller, service, repository, database, and the response travels back through the layers to the client. Now let's understand the core Spring Boot features shown in the architecture. The first core feature is auto configuration. Spring Boot examines the dependencies available in the project and automatically configures many required components. For example, when Spring Web is present, Spring Boot can configure the basic web application infrastructure. When Spring Data JPA and a database driver are available, it can configure many database-related components using the provided properties. Auto configuration reduces the amount of manual configuration developers need to write. However, it does not prevent customization. We can override the default configuration whenever the application requires different behavior. The second feature is starter dependencies. Spring Boot starters provide convenient dependency groups for common development requirements. For example, Spring Boot Starter Web includes the common dependencies required to build web and REST applications. Spring Boot Starter Data JPA provides the common dependencies required for JPA-based data access. Starters make project setup easier because developers do not need to select and manage every related dependency separately. The third feature is inversion of control and dependency injection. Spring manages application objects inside the Spring container. These managed objects are commonly called beans. For example, Spring can create the controller, service, and repository objects. It can then inject the service into the controller and the repository into the service. This means the classes do not need to create their own dependencies using the new keyword. Constructor injection is commonly preferred because it makes dependencies clear and supports better testing. The fourth feature is externalized configuration. Spring Boot allows us to keep configuration outside the Java source code. We can use an application.properties file or an application.yml file. We can configure properties such as the application port, database, URL, username, password, logging levels, and other application settings. Externalized configuration allows the same application code to run in different environments with different settings. The fifth feature is Actuator. Spring Boot. Actuator provides production-ready endpoints for observing and managing the application. It can expose information about application health. It can provide metrics and monitoring information. This helps teams understand whether the application is running correctly and how it is performing. Now let's summarize the responsibilities of each layer. The controller layer handles HTTP requests and responses. The service layer contains business logic and coordinates the application flow. The repository layer performs database operations. The database stores the application data. Keeping these responsibilities separate makes the application easier to understand, test, maintain, and extend. The controller should not directly contain database logic. The repository should not contain business decisions, and the service layer should connect the application's web layer with its data access layer. Finally, remember this quick flow: request, controller, service, repository, database, and response. The embedded server receives and sends the HTTP communication, while Spring Boot features such as auto-configuration, starter dependencies, dependency injection, externalized configuration, and actuator support the complete application. That is the high-level architecture of a Spring Boot application. Thanks for watching, and I will see you in the next lecture.